everybody, and welcome to another Houdini tutorial. My name is Kate, and today we're going to talk about something that we talked about in a previous tutorial. Today we're going to talk about a little about dark matter. I've talked about it in a previous tutorial called Building the Cosmic Web, but I thought it might be fun just to talk about it a little bit more on a less global scale of how it helps hold galaxies together and how some galaxies are considered dark galaxies because they contain more dark matter than actual visible matter. So let's get started, and we're going to start this tutorial by talking about a bunch of theory. You can skip it if you'd like to, and then just go ahead to the next tutorial, or you can just enjoy the theory and also enjoy the tutorial. So what we're going to do after we've listened to this theory, we are going to build what I'm going to call a mimicked dark galaxy. So we're going to build a very minimalistic galaxy. But let's get started and dive into the subject matter. Dark matter so let's dive into the theory. Dark matter, as we've previously talked about, forms the cosmic web in our universe. There are two types of dark matter: cold dark matter and hot dark matter. Cold dark matter is referred to as the dark material that clumps together to form galaxies, so it brings together all visible material. And hot dark matter clumps later on as it cools off, so it helps dark matter spread further up through the universe. The larger the scale, or the more dark matter collects together, the harder it is to predict. Dark matter might be capable of changing phases at different sizes. As previously discussed, it forms little rings. There's some debate of whether or not how they form those rings, but we'll talk about that later. And so dark matter might be capable of changing phases at different sizes. This is because cold states of matter condense into a superfluid. It's thought that all dark matter might form a superfluid at a galactic scale. I have an article coming out on superfluids, but I'll link that below when it's ready. A dark galaxy is a hypotheticalized galaxy with no or very few visible stars. They are mostly made of dark matter and can exist anywhere in the universe. So they have a strong gravitational pull on objects towards them, and they can edit the shape of their clouds. And that's going to be a big factor in today's tutorial. So what we're going to do is we're going to build a very minimalistic galaxy around this concept, where it's going to be clouds that we can continuously edit and based on their shape, and also have very minimalistic stars as well. So there are two types of observed dark galaxies that we've actually confirmed, and these two are listed right here, or these four. And most of them, as you can see, have numbers instead of actual names, but one is called Smith's Cloud. Scientists use different types of imaging techniques to try and observe ranges of dark matter galaxies. They primarily use imaging sources on using Röntgen, radiation, and gamma rays to create achromatic pictures of objects. So what that means is that they have to observe them in not a visible direct way, but they have to image them on a spectrum of light that we don't usually detect with our eyes. It is important to note that all gravitational lenses, a field that distorts and magnifies light, can be observed at different optical wavelengths. So that plays into the different imaging sources. So in this tutorial, we're going to attempt to build a dark galaxy, or a galaxy primarily made of dark matter, in quotations, and we will render the galaxy in two parts, one with a dark matter pass and another with a regular star render. And you can see here we have a little nebula, and you can see mostly clouds and just stars around it. So it's very minimalistic, and you can see the stars are spread out quite frequently, and you've got a cloud of visible matter, but not too much. And another thing to note about most NASA imaging is that they are composites. Usually their colors are enhanced, so we're just playing into those techniques. Another factor of this tutorial, which it might be a part 2 of this tutorial, it might not be, might be packed into the end. I will be showing you how you can edit the output of these render passes in Nuke, so you can create a more distorted galaxy type of look. Let me Google dark matter galaxies so you can get some images besides the one you see in front of you. So as you can see, this is the first results you're going to get when you Google dark matter galaxies. They are very minimalistic. You can see there's clusters of galaxies, but only very, very tiny amount of matter is visible. You have pre-composites like this. This is a falsified image. But you can see like the dark matter is very, very blurred, and that's the type of look we're going to go for. You might find regular pictures of galaxies like this. In this particular case, when you stumble across these images, they're just talking about how galaxies might be forming and holding these galaxies together, which is like Andromeda and our closest relative galaxies in our universe. So just be aware of that when you Google this topic. Research what you find. It will help. So let's dive into the tutorial and see what we can do. Alright, so here we are into our tutorial. And as you can see, I've already set up a little thing, and I'll walk you through everything in a second. But one thing I will preface this before we do anything and talk about everything so far is create your file and save it as something. The last thing you want during this tutorial is for everything to come crashing down, figuratively and literally. So what we're going to talk about first is just setting up our little render passes, our outputs, our materials, and our lighting, because I think that's the easiest way to start off this tutorial. Just get the easier concepts out the back door. So, as you can see, I have set up a little setup here. I've named this Nebula 1, but I'm going to recall it Nebula Setup, just so we can set everything clearly where it should be placed. So this is just an empty node. I've just turned all the visibilities of all my nodes off, just so I can be sure that when I'm going up and through my levels, I'm not causing Houdini to crash or overthink. I have set up a few different outputs. One is called Render Center, one is called the Render Dark, Render Background Stars, Render Front Galaxies, and Render Small Stars. And all this is just a geo node, so you can left click or tab and get a geometry node and just set that down in your scene like this. And you'll get this. So all I've done is created a geometry node and added an object merge into here. So I'll just do like that. I've done an into this object because that's going to make sure everything lines up correctly. We also have an empty object level, which I will link all our outputs to in the end. So that's all I have in each of these little output nodes right here. So what I have over here is our environment light and our camera, and that's all we're pretty much going to need because space doesn't really have a direct light source unless it's coming from a nearby star or something like that. So we have an environment light, and I've just picked an HDRI, one of the default HDRIs that come in with Houdini. So we can just turn this off and make our visibility of our HDRI disappear. For our camera 2, this is just I'm going to rename this to Render Galaxy. Yeah, Render Galaxy. Cool. Galaxy Cam might work better. So all I've done here is these are the only changes that I've made on it. As you can see, everything's pretty normal except for the aperture near clipping for clipping. So the transform, I've put it to these axes. Could even this is a very small rotation, so if you wanted to do something less small, you could just do something like that. Yeah, you don't have to get this exact specifications for the camera, but do as you will. So that's pretty much all it is, all that we need to do on this level. So let's jump over to our material palette, where I have all our materials, as you can see here. And as you can see, they're all glows, so it's pretty easy to understand, but I'll walk you through which ones they are linked to in the scene. So for the render centers is linked to glow center, and if we jump to that over here, we can see that it's a glow purple color. So what this glow center is going to be is if we observe our images here, let's say we can see some little bit of round poofs where the stars should be, or like there's stars there, but there's more visible, brighter dark matter, and that's what those centers are going to be anyway. We are going to jump out here And then we're going to render dark. And this render dark pass is going to be our main dark material pass. So you can see it's connected to another glow shader. So if we jump over here, this is the settings. It's pretty simple, same purple color as the other one. So jumping out, we've got a render background stars. So these are just smaller stars in the background of our galaxy. They're not really big. We can see in some photos that there are little tiny little specks that are very non-visible, but that's what our background stars are going to be. So as you can see, this is connected to another shader that we'll jump to. And it's just this pearly kind of white color. And it's got a glow ramp rate of 10, emission of 0.506. Pretty simple. So jumping out, we've got our render front galaxies, and what these are bigger galaxy boys right here. They've kind of got a glow around them. Or if we jump to a better image, you can kind of see here that these galaxies have got like a glow around them or a haze. So we're creating those galaxies inside that haze. The shader for this one, its settings are bigger. So we've got this darker brown color. A glow ramp rate is cranked down and the emission is cranked up. Always remember for all of these to enable emission, otherwise your glow isn't going to show. So get your glow on. So these small stars are like they're not foreground or background stars, they're somewhere in the middle. So that's what these are. So if we jump over to this shader, we can see that again it's a pearly white color and it's off-ramp rate of 4 and an emission of 12. Pretty simple. And that's all it is for materials. So I think in total there is just 5 materials. So all you need is 5 glow shaders and you're good to go. The next thing we're going to jump to is that you now understand that there's about 2 dark matter passes and there's 3 star passes. So we're going to create 2 passes, one for the dark matter, one for the stars. And if you want to get more specific, you could probably render all these 3 stars as a different pass, and that would probably give you better results. But if you're running low on time, or you're being lazy, or you're just saying, hey, they're stars, whatever, 2 is enough. So jumping out to our output, I have 2 little things set up here. As you can see, it's already switched over. You can set to our galaxy camera, and it's for the dark matter pass, it's selecting for force objects, render dark, and render at center. And that's pretty much all you need. For the rendering, it's switched over to a micro polygon physically based rendering. I did this earlier when I was experimenting, and I will have to say that you probably can go with just physically based rendering. Probably will give you a better result. And because I'm not working with volumes anymore, I'm just going to turn this down. Probably will give you better results, and we'll crank up the diffuse intensity and the global quality. Pixel samples is a 7. Even though the pixel samples are a 7, it actually renders pretty fast, so you don't need to worry about it. And my only other recommendation is just turn off candid objects, so clear that out. You don't want to render anything but the dark passes for the dark matter. For the stars, same thing. It is working on the same camera. It's working on physically based rendering. It's allowing motion blur. I would only turn this on if you wanted to render the current frame range. So I might turn that off. As for this one as well. And again, it has 7 pixel samples. Diffuse quality is 2. Volume separate is 0. And that's pretty much it, along with the candidate objects, and all this is grabbing is just our little stars over here. And that's pretty much it for the outputs, materials, rendering, and lighting. Alright, so diving into our nebula setup, which I have created up here, you can see that I've already created some starting geometry. So I'm just going to click Space G and zoom in on it so you can get a general idea of what I've done. So let's talk about what I've done and how I set it up. and then proceduralize it and create a controller so we can individualize and make the setup a lot easier. So I have two starting circles over here. Both of these streams are almost exactly identical minus the color at the end, but we'll get into that. So over here we have a starting circle. Sorry, this is pinned for some reason. So we have a starting circle, and its radius is 1, and its uniform scale is 10, and its divisions is a 1, 2, 3. So set that division scale any way you see fit. It really doesn't matter. So over here, we have almost the same thing, but if you look over here, this archetype is closed, and the archetype over here on this circle is open, and the order is actually a 4 as well. And both of these are changed up here on the primitive type. So over here, our original starting circle is a polygon, and the orientation is on the ZX plane, and the circle over here is a Bezier curve, and it's on the ZX plane. So overall, they're kind of similar, kind of different. So over here we have a mountain sop. We have a height of 5.57 and an element size of 4.9, and then some other changes were made down here to the noise settings. Over here, the noise is exactly identical, so the settings are exactly the same. Nothing to change there. So the subdivide over here, if we go over to our starting geometry, we've got it on open subdiv cat mill Clark, and the depth is a 1, and nothing else has changed. So this one over here is just a mountain circle and a convert, and the convert over here is just converting to all polygons. So zooming back up over here to our subdivide, we can see that it's subdivided over polygons. Remeshing it, we've got a mesh going on. The iterations is 10, and the tangent size is a 0.52. And this is once again converted to polygons just so everything works, and just double checking. So over here I have, let me think about something because I may or may not need these for each loops, but let me just double check. Alright, well it turned out that I didn't need them, so I got rid of them. So over here we can see that I have two copy nodes on either one of these. They should be exactly identical. So for this one, there's a number of copies is a 5, uniform scale is a 0.46. And over here should be the exact same thing. And in the translate axis for both of them, they're getting translated up by 1, so you can see these slowly getting smaller over time. Over here, we've subdivided this a little bit more. I'm going to turn off my visualizer for the points. And you can see it's made these octahedral kind of shapes. I've also given this a color, which is black. Interesting how it's not showing up right now. But anyways, we've got a color red, which is going over our lines on this side. And then finally, we have an attribute transfer, which is transferring that color. And what this is doing is that I've gone over to my attributes, I've turned off the primitives, and just kept the points option, and then added CD as the color. I think I'm going to change my background to a dark color, because it's going to be easier on the eyes. So you can see where the red color from these rings has overlapped with our black color. And if we go over here to our conditions, you can narrow down the distance threshold of how this is changing. So that's what's going on. So if we go over here to our attribute blur, it's kind of narrowing this out, and I don't like that too much. So this might be way too strong. Durations might be a bit too much. And I think this might also be a bit too much. So there we go. You can see some rings lower down here and over here, which is exactly what I want. I've then transformed this to make this whole setup bigger because I wanted a bigger galaxy. And the uniform scale is 3.6. And then I've added delete. And what this delete is doing, it's deleting delete by expression. It's on primitives, and it's deleting non-selected. So it's choosing all the colors below 0.1, so all the darkness in our little setup. And you can see all of the black is now removed. I've then added a null, which I colored yellow, and renamed outStart Geo. So hopefully that makes sense to all of you. And now it is time to proceduralize this just a little bit and make this more controlled, because there's already a lot of nodes here. So we're going to add a null, and we're going to rename this null and also give it a color. I'm going to go with red. Controller. Name it controller. And then we're going to go in here to our parameter interface. And then we're going to go over here to this wheel and turn off forbid from linking. What I'm going to do is I'm going to create a folder that's created and named as starting geo. And just copy that here. Awesome. So if we go over to our circles, we're going to do some fun stuff. I think I'm going to do mountain first, just so I can link these parameters and make them relate to each other. So, actually, I'm going to create a separate folder that's going to be under starting geo. That's going to be called attribute geo. And that's where the red color is going to be transferred from, just so we don't get that confused. So anything that is individualized under that geometry, I'm just going to keep that there. That should be good to go. So under this one, I am going to place my sphere. I think it should be left on Bezier curve. Hold on a second. Actually, we might not need this folder, so I'm going to delete it. Delete parameters. So for our starting geo, I'm going to add our circle and its uniform radius. I'm going to add underneath there because I think that should be at least be controlled by us. Our divisions as well. Open arc, I'll just leave that normalized, and radius, change that to radius circle. And then uniform scale circle. Divisions, and then circle. So we'll hit accept and apply. And we'll also add a separator just so we understand that those are part of the circles. So if you go over here, you'll notice that they've all turned green. I'm then going to go copy parameter, head over here, paste relative references. So that all should work now, and all be referenced from our controller. So we'll go copy parameter. That should work. I'm going to save before everything goes wrong. I'm not expecting it to, but who knows. So now we have our noise. So we're going to add the height in and pretty much all the changes we made. So the max octaves. I didn't change anything on the roughness or anything like that. So we'll go height, noise, and then our element size, noise, go back. and just copy paste everything into there. And then we're going to add another separator and hit apply. So those should be linked correctly. And once again, we'll copy our parameters into this one. And we should be good to go. So for the subdivide, we don't need any changes there. That should be good. Remesh. Let me take a look at this. Apply, and I wish there was a minimize button on this. It would be make things a lot easier. But we'll look at our remesh. I think we're good. You know, I'll add it just in case we might need it later in the setup. So we'll add the iterations. We'll also add the target size. The target size. So over down here, we shouldn't need to add their convert polygons. For a copy, I think we will need to add this. So once again, I'm adding down a separator, number of copies, and the uniform scale. So number of copies, pretty much cut and paste there. I don't think we need to change the name. Uniform scale copies, might have to change that. And we'll hit apply so we can copy paste that over there. And our colors we shouldn't have to change, and our subdivide we shouldn't have to change either. The only thing I'm going to change is for I'm going to add our attribute transfer to this list. And just for fun, I'm going to hit apply accept and see what our little controller looks like right now. It's kind of heavy, so I think from the attribute thing downward, I'm just going to create a different folder for these guys, just so everything looks a little bit more tidier. Geometry, and then geo, I think attrib and transform. So for the attribute thing here, the only thing I'm going to add is the distance threshold, which once again, every time you close this, you have to turn off forbid linking. So we're going to turn that into there. Distance thresholds, attrib. And then we're going to add our attribute blur, which the blurring iterations should be in here. Pretty much copy and paste there. And then our transform, depending how big you want to make this. I don't really see. So we'll make that transform scale. And then our delete, depending on how much of this setup you want to delete, we'll add in there as well. Awesome, and that's pretty much all you need for the starting geo. And I'll add a separator in between the blurring iterations and the attributes, and then we'll hit apply accept. So if we go over here and we go down to our final thing, we should see something. Blur, transform, and the delete is not working. Interesting. Ah, okay. Interesting. So, I'm going to change this. I'm going to fix this and get back to you. So, I think what I need to do on the controller is remove this delete amount because it's clearly not working. Live and we learn and we figure things out. So, don't add that to your setup and you should be good to go. And that's pretty much all you need for that step, and we'll go into the next step right now.